Hello everybody, this is your guide Akanksha Singh who will be taking you through the entire series of network security and cryptography. We are on module 2 and today I am going to cover lecture 6. We've already covered many topics in earlier lectures. I would request all of you to first go through all the lectures before lecture 6 so that you can understand the entire concept of lecture 6. So my recommendation is the prerequisite for lecture 6 is to understand from lecture 1 to lecture 5. Only when you have a proper understanding of all these lectures that have been covered earlier, only then you can understand what lecture 6 is talking about or what am I talking about in lecture 6. So let me start by today's first topic, which is principles of public key cryptography. Now, principles of public key cryptography, right? We've already seen what symmetric key cryptography is, right? We have already seen symmetric key cryptography in my first module. I told you that symmetric cryptography is the one that uses shared secret key, that is, for both decryption and encryption. Same key is used. Okay, so symmetric cryptography is a cryptography wherein shared secret key is used, and this shared secret key is same either for decryption or for encryption. Okay, so this is what is all about symmetric cryptography. Now, in the module 1, I also told you that if somebody wants to, that if two parties A and B want to distribute this shared secret key amongst themselves, right? For suppose I have to send you a message and we are talking in terms of symmetric cryptography, then I know that encryption at my side and decryption at your side, both will be using the same key. But how do we come to a decision that this is the key that we're going to use, right? There should be a distribution method. So today we'll be discussing how shared secret key is distributed among the two parties, A and B. A may be referred as sender and B is referred as receiver here. Okay, so let's see the first method that we're going to discuss of shared secret key between A and B. One method is A can select a key, right? The sender can decide upon a key and physically deliver it to B, right? That is, maybe I want to communicate to you various times, but before starting my communication, what do I decide? I decide that I will first go to you physically and then tell you that this is going to be the shared secret key for the future communication. That can be one method of delivering or of distributing the shared secret key, right? Moving on to the second one. The second one is the third party selection, wherein what happens is we leave the decision of selection of a key and delivery of the key to the third party. Third party is the third trusted party, is the one that will decide upon what key is going to be used along with along with the physical delivery of the shared secret key. It is the third party's responsibility that third party would go to sender and the receiver and tell that this is going to be the shared secret key for communicating to B, and telling B that this is going to be the shared secret key for communicating with A. Okay, so this is the second method wherein third party decides upon this key, and delivery is also the responsibility of third party. Okay, the third method is if A and B have previously communicated, right? If A and B have previously been involved into communication, and which is not very old message, just the recent one. If A and B have recently communicated and have used a key, what can A and B do now? If A and B now want to change the key, what can they do? They can use their old key for distribution of a new key, right? They can encrypt their key using the old key, and then the receiver side will decrypt the message, have the new key with using the old key. right? Can you understand? For example, we two are communicating. I came to you 10 days earlier that this is going to be our shared secret key. And after 10 days, I realized that there's a need of changing the key. What I can do is now I can use my old key to, to tell you the new key. That is the third method. Okay. But there's one problem. As you can see here, that key distribution requires that two communicants to already share a key or use a key distribution center, which makes the symmetric key cryptography prone to attacks. Right? This makes it more insecure. And this insecurity or this prone of attack to symmetric key gave rise to the another concept called as public key cryptography concept, and this is what we are going to discuss today, the principles of public key cryptography. So basically I told you why the need of public key cryptography arose, because we already knew the conventional method, symmetric cryptography, which was smooth enough, but we saw how the attackers can harm the symmetric key cryptography, or can harm the message that is being conveyed using symmetric key cryptography. So that led us to the concept of public key cryptography. So today we'll be discussing the principles of public key cryptography. Okay, so let's start. Public key cryptography is also called as asymmetric cryptography. The first thing that you have to remember is public key cryptography is also called as asymmetric cryptography. The second point that you have to remember is asymmetric cryptography is a form of cryptosystem which relies on the use of different keys, both for encryption and decryption. Right? Here for decryption and encryption, different keys will be used. As earlier we saw in symmetric cryptography, for both decryption and encryption, same key was used. But for asymmetric cryptography, which is public key cryptography, also called as public key cryptography, one and the same. Like earlier I told you, symmetric cryptography is also known as conventional cryptography. In the same manner, asymmetric cryptography is also called as public key cryptography. Okay, so the second point we saw that here in asymmetric cryptography also it is somewhat similar. Decryption and encryption algos will be there, but for both decryption and encryption algorithm, the difference will be that we will be using different keys. Okay, so this is the first point that you must know. Now the third point is that it is computationally infeasible to determine the decryption key if you are given the knowledge of what is the cryptographic algorithm along with what is the encryption key, right? Can you understand what I mean to say? I mean to say that if you're knowing what is your encryption algorithm, for suppose, and if someone knows what is the encryption key, even then that person will not be able to decide what will be the decryption key. That is, for suppose the attacker knows what is encryption algorithm along with what is the key that is going to be used for encryption, even then it is going to be infeasible, computationally infeasible to determine what will be the decryption key. That is the strength of asymmetric cryptography. Okay, so the third point is it is computationally infeasible to determine decryption key even if someone has knowledge about encryption algo plus the key. Okay, so this is my third point about public key cryptography. Now let us understand the different components. If you remember, when we started with symmetric cryptography, I also told you about components of symmetric cryptography, and today we'll be discussing about the components of asymmetric cryptography. Okay, so the components of asymmetric cryptography are: the first component is the plain text. All of us know the plain text is the usual text in which we communicate. Okay, the second part is the encryption algo. The third part is the public and the private key. Since here two different keys will be used, so their names are public and private key. Okay, all of us know that two different keys will be used in asymmetric cryptography, one for decryption, one for encryption, and one will be called as public key, another will be called as the private key. Remember this. The fourth part is the ciphertext. All of us know that the ciphertext is the one that that is a scrambled message that has the hidden meaning. Okay. The last one is the fifth one, which is the decryption algorithm. So I hope nobody has problem till here. Right. So this is all about asymmetric cryptography. Asymmetric cryptography is also called as public key cryptography. The decryption and encryption in asymmetric cryptography uses different keys. It is computationally infeasible to determine the decryption key even if someone has the knowledge about encryption algorithm and key. And the components of asymmetric cryptography are the plain text, encryption algorithm, two different keys, public and private, ciphertext, and decryption algorithm. Right, so now we'll be discussing the encryption methodology in asymmetric cryptography. So the encryption methodology in asymmetric cryptography, how does it take place? To explain you, I'll explain you in the stepwise pattern so that you can understand it very easily. The first thing is that each user generates a pair of keys. Okay, anyone who wants to communicate will first generate the pair of keys. For example, if I want to communicate, I will first generate pair of keys. That is, I will generate two keys. Okay, one for encryption and other for decryption of a message. Okay, the first step is each user has to decide upon two keys. Right? This is the first step. One for encryption and other for decryption. The second step is now the user has to place one of these two keys. The user has to place one of these two keys in a public register or other accessible file that is seen by everybody. Okay, so user is supposed to keep one of these keys into a public directory or into a file where everybody can see that file and see what is the key. Okay, understanding? User will generate two keys. One will be public, one will be private, out of which the public one, he will announce this public key to everybody. For example, I want to communicate, I decided upon the two keys, and one of them will be public, another will be private. And what will I do? I will announce my public key to everybody. So the method of announcing is placing public key into a accessible directory or file. Okay, so this is the second step. The third step is always remember whatever thing that I've announced or whatever thing that I've kept, whichever key I've kept in accessible directory or file is the public key, okay, not the private one. Okay, moving on to the third step. If someone wishes to send a confidential message to someone else, what the sender will do? Sender will then encrypt the message using the receiver's public key. What do I mean by this? Now, for suppose you want to communicate to me, right? If you want to communicate to me, what would you do? You would move to the accessible directory, see what is my public key, and then encrypt the message by my public key, right? If someone wants to communicate to me, that person will go to the accessible directory or the file, will see what is my public key, and then communicate or then encrypt the message by my public key. Okay, so this is if A wants to communicate to B, A will first go to the accessible directory and see what is B's public key, and then encrypt the message using B's public key. Okay, so this is the third step. I hope you've understood this. Now moving to the fourth step. The fourth step is when the receiver receives the message, right? When the receiver receives the message, what receiver will do? That is, when you want to communicate to me, you saw what my public key was and encrypted the message and then sent the message, right? After I received the message, what I will do? I will then decrypt the message. How will I decrypt the message? I will decrypt the message by my private key, right? That is, A was to send a message to B. What A did, A first picked up the public key from the accessible directory, encrypted the message, and then send it to the B. And after B received the message, what B will do? B will then take his private key and decrypt the message. Decrypt the message using private key of its own, right? So this is the fourth step. Very simple. I hope you've got the entire procedure. The first thing is, any person who decides upon sending a message will decide two keys. After deciding the two keys, that is, one is private, one is public. The public one, he will announce it. How will he announce it? He will announce it by writing or placing that key onto an accessible directory. After doing this, what it will do, if someone wants to send a message to someone else, or someone wants to send a message to B, what will he do? He will then see what is B's public key and encrypt the message using the B's public key. And after A receives the message, after B receives the message, B will then decrypt the message using its own private key, right? So this is the entire methodology. One more thing, with this approach, all participants have an access to the public key and private key, which are generated locally by each participant, and therefore need of distribution of key is completely eliminated, right? So here basically the distribution of the key is eliminated. How? Because each participant is given the choice of choosing the key by its own. So the diagram, I would like to also make a diagram for understanding. If this is the plain text, and after which I have the encryption algorithm. For encryption, always remember public key will be used. After which the message will be transmitted. And then decryption. In decryption, private key will be used. And only then you will be getting a plain text, right? And this public key will be, if this public key is of B, the private key will also be of B. Okay, so this is the entire methodology of asymmetric encryption technique, right? So this is the public key encryption technique or asymmetric encryption technique. We will be moving ahead to my second topic, which is the RSA algorithm. So coming on to RSA algorithm. Now RSA algorithm stands for Rivas, Shamir, Edelman. All these three scientists together proposed the concept of RSA algorithm. Now the general purpose of this RSA algorithm was to generate a public key encryption technique. Okay, so Rivas, Shamir, Edelman together generated a concept for public key encryption. Now moving ahead to what this encryption technique is. Remember that this is an asymmetric technique because it is a public key encryption technique wherein the encryption and decryption both will be using the different keys. Okay, if you remember that encryption will be using public key, and decryption will be using the private key. Okay, so moving ahead to RSA. RSA scheme is basically a block cipher scheme wherein the plain text or the ciphertext are going to be between 0 to n minus 1 for some n. Okay, so typically the size of this block is is 1024 bits, right? So this is the size. Always remember that RSA is a block cipher technique and not the stream cipher technique. If you remember, block cipher technique is an encryption technique wherein block by block conversion of plain text is done into ciphertext, right? The size of the block typically is going to be 1024. Moving ahead, Rivest Shamir Edelman algorithm is going to use two different keys, private key and public key, as all of us know. Now the public key is going to be referred as E comma N, and private key is going to be referred as D, P and Q. Okay, so let's see how these two keys will be generated. All of us know that the generation responsibility is the responsibility of the one that is going to communicate. Okay, so that is one's responsibility. So one can use RSA technique for generating private and public key. Moving ahead to understanding how one will generate the private and the public key. Okay, so there's an algorithm for deciding the two keys. Let's see how they can do it. Start by choosing two very large numbers. Start by choosing two very large numbers that are P and Q. Remember that these two large numbers should be prime numbers. Okay. Second step is find out a product. Find out a product of P and Q and store it in N. Okay. The third step is find out Euler-Torsion function. If you remember Euler-Torsion function, what it does, it counts the number of relative primes that are equivalent less than n. Okay, so Euler-Torsson function of prime numbers, if you remember prime number, I told you if you have to find out the Euler-Torsson function of 7, what will be the count? Count will be 6. Similarly here, since these are prime numbers, the count will be 1 less than the prime numbers. So Euler-Torsson function of p and q is going to be p minus 1 dot q minus 1. Basically we are finding out the Euler-Torsson function of n. So this is the shortcut of finding out the Euler-Torsson function of any prime number. Moving ahead. Now next to the fourth step is choose an integer e. Now how are you supposed to choose an integer e? Remember, you have to choose e such that e is lying between 1 and the torsion function, such that e is lying between 1 and the torsion function, right? Also you have to remember one more thing, that the GCD, greatest common divisor of e and torsion function, must be equal to 1. That is, both e and torsion functions must be equivalent to 1 or must be relatively prime. Okay, so moving ahead to the fifth step, after choosing e, what you will do is then you will compute d. How will you compute d? See how you will compute, such that e multiplied by d is congruent to 1 mod phi n. Okay, one more thing, here d should also lie between 1 and torsion function n. Okay, and then after computing all these values, the public key is n and n comma e as told you earlier, and the private key is dpq. Okay, we have discussed this earlier also. The private key is dpq and the public key is n comma e. So out of all these values, my e and n is going to be public and my dpq is going to be private. Now after seeing this algorithm, there will be a definite doubt as to how this is to be done, right? Okay, let me take up an example. Let's select two prime numbers. I'm not going to select very large prime numbers because then I will be having a problem in solving a question. So basically I will be selecting two prime numbers which are not very large, but in real examples what is done is p and q are supposed to be very large prime numbers. After doing this, step number 1, I will be calculating n, that is p into q, which is 17 into 11, that is going to give me 187. After which I will compute the Euler-Torsson function. Euler-Torsson function, how will I compute Euler-Torsson function? P minus 1, which is 16, into q minus 1, which is 10, so 160. 160 is going to be the torsion function of n, after which I have to choose an integer e. I have to choose an integer e that is relatively prime to phi n, that is relatively prime to phi n. My phi n value here is 160. So I have to choose a number e such that it is relatively prime to e. So my e can be 7, right? If I choose 7, you can choose any other e. There is no hard and fast rule of choosing e as 7. Sometimes in numericals the choice of e is also given, sometimes it is not given. So choose a e which is simpler at your end. Okay, so e is 7. I've chosen e to be 7 because e is lying between 1 to phi n, and when we find out a GCD of 160 and 7, greatest common divisor is 1, so therefore they are relatively prime. After which I will move ahead to determine d. Now how will I determine d? I know my formula for determining d is congruent to 1 mod 160. My e here is 7 as I know, and 1 mod 160. Okay, this is what I know. So what do I multiply to e to get still 1 as congruency in forms of mod 160? I've already told you for the solution how to solve this. Here I will not be going into detail of solving this congruency. So my answer for D is going to be 23. In case you have doubt, please go through my earlier videos wherein you will find out how to solve congruency. So this is the entire explanation of the algorithm, the RSA algorithm. Thank you, class. We'll be meeting in the next lecture and understanding what discrete algorithm is. Please stay tuned to all my lectures to understand entire concept. Okay, thank you so much.